All right, so this is a new feature that I'm doing, and that is I'm going to record some chapter reviews. All right, so this is a chapter review for Chapter 5, if you're using the Bob Jones Pre-Algebra, latest edition, and we're going to review equivalent fractions, reducing decimals, mixed numbers, ratios, rates, and proportions. Now, this is designed to just watch, so I'm going to go fast. So all you want to do is watch. I'm going to give you a quick review. All right, first thought. Rational numbers are fractions. All right, remember, rational numbers are just fractions. When you got to change a mixed number to an improper fraction, be careful when the quantity is negative. See that negative there? So remember, I told you when you're converting, put a negative sign and a parentheses. That's the key. All right, and then what do? Take the whole number, the 4, multiply it times the denominator, the 9, add in the numerator, the plus 5, and you're going to put it all over that 9, right? Okay, so what do we got? 4 times 9 is 36. 36 and 5 is 41. So it is a negative 41 ninths. Okay, that's all you got to do. Pretty simplistic, but you got to remember the negative and the parentheses to get that numerator correct. All right, the second example over here to the right is simply, hey, change this into a mixed number. Remember to do that, you're simply going to divide the denominator, the bottom, into the numerator, the top. 5 goes into 42 8 times. That's a 40. What's our remainder? 2. Make your remainder a fraction. By the way, you would reduce that fraction if it were reducible. 2/5 is not. If it were, you would reduce. Okay, next concept here. Let's deal with reducing fractions to lowest terms. So I've got a fraction over here. We've got 28/42, and we're going to reduce it. So remember, this is the way I taught you guys, and if you reduce this way, you can reduce anything, even polynomials. What's a 28? A 4 times 7. What's a 4? A 2 times 2, okay? Let's do our 42 on the bottom. What's a 42? A 6 times 7. What's a 6? A 2 times 3. Now I'm looking to divide common factors. 2 on the top, 2 on the bottom, divide them out. 7 on the top, 7 on the bottom, divide them out. That's it. No other common factors. What's left? 2 on the top, 3 on the bottom, and away you go. All right, next thing. Let's go ahead and evaluate. So if you get a problem like this and it says evaluate, you want to substitute in the values for the variables. Now remember, we put parentheses wherever there's a variable. All right, so I put a parentheses wherever there's a variable. Where the B is, I put in a negative 4. Where the C is, I put in a 5. And where the D is, I put in a 10. All right, let's do evaluate all exponents first. 5 squared is 25, right? Now it's all multiplication division left to right. This is technically a multiplication. That's a 4, right? Negative times a negative is a positive. This multiplication, 2 times 5 is 50, and we have a 10 on the bottom. Now we got to do this division. 5 divided by 10. Whoops, and I see somehow that plus sign snuck in there, right? I caught myself there. This is a negative. So now we're going to have the 4, the negative. What's 5? 50 divided by 10, that's a 5. 4 positives and 5 negatives leaves you 1 negative. And voila, and away you go, and you're good to go, right? All right, what else? How about something like this? How about writing equivalent fractions? Writing equivalent fractions. So you'll be asked something like this. Write a fraction equivalent to negative 5/8 with a denominator of 56. Okay, so remember, what you're trying to do is take the current denominator, an 8, and end up with a denominator of 56. So off here is what you should be thinking. You should be thinking, hey, that 8 times what will equal this 56? The 8 times what will equal that 56? That's your thought process. And hopefully you think 8 times 7 is 56. Therefore, then that 7 goes in the bottom. And remember, an equivalent fraction, whatever you put in the bottom, you put the same thing in the top. Now I'm ready to finish off the top. Negative 5 times a 7 is a negative 35, and there's the equivalent fraction, negative 35/56. Okay, what else? Remember, we can compare fractions by cross multiplying. Is negative 7/9 greater than, is it equal to, or is it less than a negative 4/5? Now remember, it's top times top. So negative 7 times 5 is a negative 35. And then it's bottom times top. Did I say top times top? So top left times bottom right, negative 7 times 5, negative 35. And bottom left times top right, 9 times negative 4 is a negative 36. And now you have to think, is negative 35 bigger than or less than negative 36? It's bigger than, right? So it's greater than. Therefore, the negative 7/9 fraction is greater than the negative 4/5 fraction. So it's a simple way to figure out whether one fraction is greater than, less than, or equal to another fraction. You simply cross multiply. All right, what's next? How about to change a fraction to a decimal? All right, remember, that's pretty easy. Just divide the bottom into the top. Now I did one that's negative just to remind you, right? So what I always do is take that minus sign, put it up top, change that to a plus. All right, 11 goes into 70 how many times? And hopefully you agree that that is 6. That's a 66. Subtract, you get a 4. Need another 0. 11 goes into 40 3 times. That's a 33. All right, so 33 and remainder of a 7. All right. And oh, look, we're right back where we started. I have a 7 there and a 7 there with a 0 to come next. So I'm at the repeater part. Now, again, if you don't recognize that, you can keep going and you'll get 6, 3, 6, 3, 6, 3, 6, 3. I recognize the repeat 7 and I know the pattern's going to continue. Okay? So again, it's a 7 with a 0 to the right, as this will be a 7 with a 0 to the right. Therefore, this part repeats 6, 3. Again, if you can't figure that in your head, just do a few more places and you'll see it's obvious. Okay, how about the second situation here? Let's take 5 3/8 and let's convert it into its decimal form. Now, you could change this into an improper fraction and then divide it. But it's really easy if it's a mixed number. The 5, just go ahead and put it up there as your numerator, and it's going to be 5 point whatever an 8 into 3 is. See, the whole number is going to be the 5-point part, and the fraction part is going to be the decimal part. Okay, so 8 goes into 30 how many times? And hopefully you say 3, and I get a 24. 24. I'm already thinking ahead to that remainder of 6, right? And then I need another 0. 8 goes into 60, 7. 8 times 7 is 56. And I get a 4. Another 0. 8 goes into 40 5 times. And there it is, no remainder. And the answer 5.735. So the whole number is the part to the left of the decimal point, and the fraction becomes the part to the right of the decimal point. Okay, what else? Well, we talked about ratios this chapter, right? Ratios and rates. So ratio, what is that? A comparison of two numbers. And remember, there's 3 ways to write it. Oh, I'll just pick 5 and 2. So we can say 5 to 2. We can use the word 2, or we can use the colon, which is still read 5 to 2. Or it can be in fractional form, 5 over 2. Hey, remember, you're always going to reduce, so you do want to reduce all fractions and oftentimes the other ratios as well, because lowest terms is best. Okay? What else did we talk about? We talked about a rate. Remember, a rate is a ratio, a fraction, but you have 2 different kinds of measures. For example, how about something like this? 27 feet per second. That's a rate. How about this? 19 miles per gallon. All right, these days we're not happy with a vehicle getting 19 miles per gallon, but that would be a rate. Remember, when the rate involves money, it's going to be called a unit price. So here's grocery store unit price right there, right? And by the way, if we were to write this, we would include the dollar sign, right? So this is $0.263 per every ounce, okay? A unit price. So what if they gave you the problem like this? They said 5 pounds of plums sell for $15.95. What's the unit price? Well, remember, the money is always in the top and the amount is in the bottom. Now, how do I figure out the unit price? I got to divide the bottom into the top. All right, you got to divide the bottom into the top. I always like to keep my dollar sign. 5 goes into 15 3 times. No remainder there, but we still bring down the 9. 5 goes into 9 once. Bring down the 5. 5 goes into 45 9 times. And now we have, finish it off now. Remember, unit price has a unit on the top, which is dollars, and it has a unit on the bottom. This is per pound. Don't forget the per pound. So $3.19 per pound. And there you go. All right. What else? A couple more things. How about proportions? What are proportions? They are simply two ratios or fractions that are equal. So if you look over here, you get a half and equals 21/42. That's also a half, right? Or 4/8, etc., etc., 5/10, whatever. Now remember terminology. The top left and the bottom right are called the extremes. The bottom left and the top right are called the means. And remember, you can solve a proportion by multiplying extreme times extreme, and that will equal mean times mean. This is a great method when your variable is in the bottom. So let's do it. -4 times n is a -4n. 3 times -20, I'm going to leave that. 3 times -20. Say, Mr. Scarfy, why did you do that? I'll show you in a minute. All right, we want to isolate the variable, right? So the shortcut is divide both sides by -4. On the left, that leaves you just the n. Hey, look at the right here. What is a -20? A -20 is a -4 times a 5. Do you see now how I can divide out these -4s? Oh, yeah. What am I left with? 3 times 5, that's a 15, and equals 15. Voila, we are done. Okay? So very, very handy to have the extreme times the extreme equaling the mean times the mean. That's how you want to solve a proportion when the variable is in the bottom. Now our last example, we're going to make a proportion and our variable will be in the top. So remember, I told you whenever you make a proportion, it's always best to put the variable in the top left. All right, so we got a word problem. Sal can run 440 meters in 44 seconds. At this pace, how long will it take him to run 600 meters? All right, we're going to name the variable. What are we trying to find? How long. So what is that? That's time. So our variable is time. Always NTV, name the variable. All right, remember, we put the variable top left. It's easiest. And again, I'm going to put what it represents, and that's time. That's important. Now, which unit, the 440 meters, the 44 seconds, or the 600 meters, goes with this time that we're looking for? And I have it color-coded, so it's easy. Well, the 600 meters. And again, I like to make my proportions with the things that go together as the top and bottom of a fraction. So 600 meters goes in the bottom. Now I have two things left, 440 meters and 44 seconds. Now remember, it's important you put them in the right place. Notice my left fraction has time in the top. Therefore, my right fraction must also have time in the top, 44 seconds. Therefore, that leaves the 440 meters in the bottom, just like my left fraction. Now I've got everything correct. Hey, this is a very easy thing to solve. I could cross multiply extreme times extreme, mean times mean, but honestly, I'll have a 3-step problem if I do that. Let me instead just go ahead and solve this by moving the 1 over 600 meters. How do I do that? Multiply both sides by the reciprocal, right? Multiply the left by 600 meters over 1. Multiply the right by 600 meters over 1. If you look on the left, your 600 meters divide out, leaving you the variable and isolate it all by itself. Hey, on the right, we're going to hope we can reduce, and look, we can. What's a 440? Isn't that a 10 times 44? So now we can take the 44 on the top and divide it by the 44 on the bottom. Cool. Not only that, a 600, isn't that a 10 times 60? It is. So let me use my black here. Now I can take this top 10 and divide it by this bottom 10, and they're gone. Now wait a minute. One more thing. Let me use my purple here. Don't neglect the units. I have a meter and M on the top, and I have a meter and M on the bottom. They also divide out. What do I have left in the top? And because I used my units, it's all there. I have a 60 seconds, and there's nothing left on the bottom. Therefore, n equals 60 seconds. All right, that's the quick review of the chapter. You should work on areas that are problematic to you by using odd problems from either that homework section or from the chapter review. Hope you do great on your test.